So far we've been solving equations. We solved one-step equations, then two-step equations, then multi-step equations. The nice thing about solving equations is we always came up with a number for our answer. We could check that answer by putting that number back into our original equation. Today we're going to be rewriting equations and formulas. And the catch is that you're not always going to come up with just a number for your answer. And it's not always going to be the easiest to check. So what we have to do is realize what is and is not a variable in our equations. So in example 1, they want us to solve ax plus b equals c for x, and then use that to solve 2x plus 5 equals 11. So we'll just hang on to that 2x plus 5 equals 11 for a minute. They want us to solve ax plus b equals c for x. In other words, we want to end up with x equals something else. Now, here's what you have to remember. When we're solving for x, we can treat everything else in the equation, well, not like the plus and equal signs, but you can treat the other letters in the equations as if they were numbers. Okay? You can subtract them, multiply them, divide them. Obviously, you can't like combine them because if you don't know what C and B are, you don't know what C minus B is. But we can treat them just like they're numbers. So I want to get X all by itself. So if A, B, and C were numbers, what would I do first?
Subtract B to both sides.
Subtract B from both sides. So now we'd have AX equals C minus B. So I've got AX equals C minus B, and I want to get X by itself. What do I do now? Divide? Divide A from both sides. So if I divide A from both sides, I'm left with X on the left equals C minus B over A on the right. Now, if you're going to write that as two different fractions, you don't have to, but if you are, A has to go under the C and under the B. Okay, it's part of both. Everybody good so far? That's the first step there. That's solving the equation for x. That's rewriting the equation so that you have x equals. Now, we want to use that to solve 2x plus 5 equals 11. Let's think about this. If we compare 2x plus 5 equals 11 to ax plus b equals c, what's a? What's b? What's c? 11. So all we have to do is go back to our rewritten equation and plug those in. X equals c, which is 11, minus b, which is 5, over a, which is 2. What's 11 minus 5?
7.
What's 11 minus 5? 6. Divided by 2 is 3. Any questions yet? All right, let's look at the next one. There's another way they're going to word these same types of problems. They're going to say, write 3x plus 2y equals 8 so that y is a function of x. What they mean is solve it for y. So you have y equals something with an x in it. So we're going to treat the x kind of like it's a number. Okay, we still can't combine anything that's not like terms. Okay, you can't combine 2 plus x if you don't know what x is. But we can move it around just as if it were a number, and we're going to solve for y. So I want to get y by itself. What's going to be my first step in getting y by itself? Go ahead, Sarah.
Subtract 3x from each side.
Subtract 3x from each side. So we got 2y equals 8 minus 3x. Or you could write negative 3x plus 8. Either way. Again, we're trying to get y by itself. I'm just going to put that in parentheses so we know that's an alternative form, not a requirement. So what am I going to do now to get y by itself? Divide both sides by 2. So if I divide both sides by 2, I get y equals 8 minus 3x over 2. Now again, if we want to separate those, we would put the 8 over 2. What's 8 divided by 2? 4. And the 3x over 2. Or you can just put the 3 over the 2 and the x out next to it. Okay. For that matter, you could do it in the other order just like we did above it. Okay. The important part is to remember that when you have a sum or a difference divided by 2 or whatever number it is, you have to divide each piece. Okay? So any one of those is a perfect final answer. I don't care which format it's in. 8 minus 3x over 2 or 4 minus 3 halves x or negative 3 halves x plus 4. Any one of those will work. The important thing is that we have y all by itself, and the right side is simplified. Okay, there's nothing that we can reduce altogether. Okay, we could do this with formulas too. In example 3, the area of a triangle is given by the formula area equals 1/2 BH, where B is the base and H is the height. Solve the formula for the height H. So we have a formula where we know, if we know what B and H is, we can find the area. Now we're going to rewrite this so we have H equals, because they want us to solve for H. So what will I do first to get H by itself? Let's put it this way. We've got a couple of things attached to the H. What do you want to get rid of first? Okay, how would I get rid of the 1/2? We can divide by 1/2. What's the other way of dividing by 1/2? Multiplying by 2. Okay, we can multiply both sides by 2. Gives us 2a equals bh. Again, we're trying to get h by itself. So how do I get rid of the b? Lauren? Divide. It's being multiplied by the h, so we get rid of it by dividing. So we have h equals 2a over b. Okay. So now we have the formula solved for height. So our original format was a equals 1/2 bh, which is helpful if we know b and h and we want to find the area. So if you know the base, now you can find the area. Now, if we know the area and the base, we have a formula that will give us the height. So they give us the example with a triangle with a base length of 14 meters and an area of 64.4 meters squared. So all I have to do is plug those in to solve for h. So we have h equals 2 times 64.4 over 2, or sorry, not over 2, over 14. What do we get when we simplify that? $9.2. Okay. So we'd be doing 2 times 64.4 and then dividing the result by 14. Any questions yet? All right, let's look at a really fun one that you're going to see a lot. I think I cover this type of example in just about every class I teach. You are visiting Toronto, Canada over the weekend. The website gives the forecast shown. Find the low temperature for Saturday and Sunday in degrees Fahrenheit. Use the formula C equals 5/9 times F minus 32, where C is the temperature in degrees Celsius and F is the temperature in degrees Fahrenheit. So what we want to do is we want to find all of those temperatures in Fahrenheit, because we're in Canada, they're giving us temperatures in Celsius, and being Americans, we like to read our temperature in Fahrenheit because that's the scale that we understand better. So what you could do is we could take the formula that they give us and plug in each one of those individually. And we could say C is 21, and we got 5/9 times F minus 32, and we could solve that for F. Then we could plug in the next number and solve it for F, and plug in the next number and solve it for F, and plug in the next number and solve it for F. But it would be faster if we rewrote our equation so we had F equals, and then plug in all of the numbers. Rather than having to solve each time, if we rewrite it in terms of F, so we have F equals, it'll be a lot faster. So let's start with C equals 5/9 times F minus 32. We want to solve for F. What do we need to get rid of first? Okay, how do we get rid of the 5/9? You could multiply, but that's going to give me more fractions, and I don't want to have more fractions than I started with. So there's a shortcut around that. How can I get rid of 5/9? You have an idea, Sarah? And what do I do with the reciprocal? Nope, that's what she said. I don't want to distribute. You're right about using the reciprocal. Well, we divide by 5/9, which is the same as multiplying by the reciprocal. Okay, so if we multiply both sides by the reciprocal, that will keep us down to just one fraction. What's our last step? Add 32 to both sides. Now, this type of problem is one exception to the rule. Normally, I tell you that if your problem has fractions in it, your answer should be in fractions. If your problem has decimals in it, your answer should be in decimals. This is going to be the one exception to the rule. Well, not the one. It's going to be one of the exceptions to the rule, because usually when we're giving a temperature, we don't usually give it with fractions. Nobody says it's 57 and 5/9 degrees outside. Okay, that just sounds silly. We use decimals. So what we would do to find each of our temperatures in Fahrenheit is we would just take and plug in each one. So we would do 9/5 times 21 plus 32. And we would do 9/5 times 13 plus 32. Well, we wouldn't need to do Friday because they asked for Saturday and Sunday. But you get the idea. Does that make sense? And make sure when you write your answers that you label, this is the low for Saturday, high for Saturday, low for Sunday, high for Sunday. Everybody okay with that? Any questions? Okay.